Yes, welcome to the part 1 of season 3 in the Keio International Christian University Linguistic Colloquium. I'm Seunghun Lee from International Christian University, and this event is co-hosted with Shigeto Kawahara from Keio University. Today, we have 2 exciting talks by Youngah from the University of Hong Kong and Adam McCollum from Rutgers University. So let me introduce Youngah. Youngah is currently an assistant professor of linguistics at the University of Hong Kong. She works on phonology and its interface with phonetics and morphology. Her interest is wide in many different areas of linguistics, and she's also interested in experimental and computational exploration of phonological acquisition. We just heard that 2 of Youngah's paper will appear soon in the journal Language, and also Phonology. Let's congratulate her on that. I met Youngah for the first time when we were both in the States studying, and then since then we had like constant communication. So it's just nice to see Youngah here at the Keio ICU Linguistic Colloquium. Today, Youngah will talk about variation awaiting bias, substantively biased learning of vowel harmony variation. Welcome, Youngah. You are muted, Youngah. Yeah.
Hi, thanks. So shall I start by sharing my screen?
Yes, you can do that. Yeah.
Okay. Okay, let's see. Is it shared? Is the full screen shared with everyone now?
Yes. Yes.
All right. Okay, so let me start. Thank you for having me, and thanks for the introduction. So today, let's start by first looking at this similarities between the phonological learning and phonological typology. For the phonological learning, a set of phonemes that share a single feature is better learned than a set of phonemes that's shared by the multiple feature, and such tendency is well reflected in typology. In terms of the phonotactics, learners better learn the consonant clusters with the rising sonority profiles than the clusters with the falling sonority profile. And we can see a typological implication between the 2 cluster types in the languages. In terms of the alternations, postnasal voicing is better learned than postnasal devoicing. And if we look at languages, there are way more languages with postnasal voicing than postnasal devoicing. So as a way to understand this link between the typology and learning, one hypothesis concerns that it must be learning biases that is shaping our languages. The big assumption here is that language is always undergoing changes. It's a dynamic system. And our typology reflects sound changes, which then reflects learner's bias or learner's preference among the other factors. So for example, let's consider this consonant cluster example again. Learners will better acquire the clusters with a rising sonority than the falling sonority, and this is learner's learning preference or learning bias. Because of this bias, the learning tendency will be reflected in sound changes, which will then be reflected in our typology. When we look at the work that's investigating the phonological learning biases, there are a lot of work that's already done in the field. And in the field of phonology, primarily there are 2 types of learning biases that have been actively investigated. One is what's called a simplicity bias or complexity bias, meaning that the phonological forms defined or processed with a single feature is learned better than the phonological forms defined in multiple features. And another type of a bias is called a substantive bias. The forms grounded in phonetic factors are better learned than the forms not grounded on phonetic substance, such as the postnasal voicing versus postnasal devoicing. When we look at the work that investigated the phonological learning biases, we know that there is a critical gap in the literature. Most of the work looking at the learning biases, their assumption is that phonology is a categorical. Here's what I mean by categorical phonology. So consider this mini language, language A, where pataka always appears at the end of the word and bajaga always appear in the intervocalic position. Here is quite simple because as a learner, you will find that it's always the case, exclusively the pataka is always in one phonological context and bajaga is also exclusively in one phonological context. But when we consider the natural language phonology, our phonology is not that simple. Among many factors that make our phonological system complicated, one such factor is variations. Variations do exist in many languages, and it's a lot. For example, in English, we can see the phonological variation at the word level, like in cat and cat. And it's not that learners need to, it's not only that learners need to figure out the multiple variants as such, but they also need to figure out the stochastic phonological variability, such as in the example here. For example, if there is a CC cluster at the end of the word, learners need to figure out that once is followed by the consonant initial word, it's more likely to drop the final C as in last call than realize T as in last call. So learning variation brings us a great challenge. If we consider some linguistic and social factors, the variance shapes and their distributions are partially predictable. If we understand the phonological environment, for example, for the consonant dropping in our last call example, we can guess why T is better dropped in this environment. However, the predictions about the variance distribution or the shapes are never deterministic nor absolute, so this is a great challenge for phonological learning. The goal of the motivation of this study is as follows. So recall that the main goal of this research program is to link the learning with languages. We want to understand why our languages look in a way that they look like through the lenses of the learning tendencies. So given that languages involve not only categorical phonological patterns, but also variable patterns, we need to consider the learning biases, both in terms of the categorical pattern learning, as well as the probabilistic or non-deterministic variable pattern learning. That's why we need to consider any learning bias component with the incorporation of the variable learnings. In fact, it's not the first that we looked at any variation learning in the field. Especially in syntax, there are quite a lot of work already done that look at the role of the learning biases in syntactic variation learning. And the goal here is almost the same as in phonological learning bias studies. They wanted to understand where these typological asymmetries come from through the learning component. For example, let's consider this word order asymmetries. If we look at word languages, as in table 1, we can see that there are some asymmetries we can find from the word order. As we can see from 27% and 52% in table 1, there are more of the languages where adjective and numerals comes in the same position in relation to noun. For example, 52% of the languages, they have a noun comes first, followed by adjectives and numerals. It's quite rare to find languages where the position of adjective and numerals are opposite in relation to noun. So as a way to understand such typological asymmetry, what they did in the experimental setting is that they wanted to figure out whether learning actually reflects such typological tendency. In other words, in the experimental studies, they wanted to figure out whether what they call the harmonic word order is learned better than the non-harmonic word order. In table 4, language number 1 and language number 2, those involve harmonic word order because both of the languages have the same adjective and numeric positions in relation to noun. And language 3 and language 4, they have a non-harmonic word order. And because those word orders are not really absolute, how they designed this the language is they put the variability in the design of the languages. For example, if you're a learner of a language 1, 75% of the times you will see numeric followed by the noun, but the remaining 25% of the times you will see that the noun comes first followed by numeric. Across the various results in the syntactic variation learning, let me first summarize in a very schematic way what they found. If you look at the results from the adults, what we can see is that adults are very great in tracking the proportion of the variance. In other words, they have a slight modification of the proportion of the variance toward the majority pattern, but most of the times they are really good at figuring out the proportions that's shown in the input. But for the children in the syntactic variation learning, they show a totally different pattern from the adults. So for the children, they choose one pattern, which normally is best supported from typological consideration, and they completely regularize it even when that pattern is not the majority pattern. For example, let's consider this word order example that I gave you. Here's a result from the Culberson and Newport paper. When children are trained in the languages where we can find the harmonic word order and non-harmonic word order, regardless of the patterns that's shown in the input, what children did is that they chose the harmonic word order, which is their preferred pattern. And they always thought, almost always, like 90%, that that is the correct answer, and they regularize it completely. If you look at the phonological variation learning, though, compared to the syntactic variation learning, not much of a work has been really done that look at the learning biases involving the inherent variability. My own work with Shannon Mooney, we tested a type of a bias. Recall that the substantive bias is the bias proposing that the patterns grounded on phonetic substance will be learned better. We tested that bias in learning free variation of a rounding harmony. Our participants were the adults at that time, and we designed two languages where in one language, rounding harmony was a dominant pattern, and in another language, non-harmony was a dominant pattern. And here is a brief summary of what we found. When we look at the adults' learning of a rounding harmony, we were able to see that adults boosted the rounding harmony compared to the input. It's not very radical, but still the harmony pattern was observed more in their output compared to the input that's shown during the training. So our argument is that our variation learning is biased. Instead of going toward just a simple way, meaning canceling the one variant and choosing only one that is true, but adults' learning of the variation is quite substantively biased. They learned the two variants, but they modulated the proportion of the two variants in a way that the natural variant is better represented in their output. So this is our results by item. For now, you don't really need to worry about the item names like Tutrugbu or Tutrugbu, but what I want you to focus on is the comparison between input and output. Here, in the two graphs, the red lines in both of the graphs, they show the proportions of the rounding harmony shown in the input. For example, on the left graph, rounding harmony language, you see that the 67% of the times the rounding harmony was shown to the participants. And it was only 33% of the time rounding harmony is shown in the non-harmony language. And as we can see here, although there are quite a different variabilities among the different items, but still there's rough match between input and output, and there is a slight increase of a rounding harmony in the output compared to the input. So today this talk is basically a modification of our previous study, and we are applying the same study, replicating the same study to the child participant. So the theme here is the child learning of rounding harmony variation. Just like our earlier study, our target pattern is variable rounding harmony. And we changed the population this time to Hong Kong Cantonese speakers, and these are the child learners. The experimental paradigm was our artificial language learning paradigm. Before we jump into the details of this experiment, let's first consider why we ever need to consider the child learning of a phonological variation. For the variationists in social linguistics, they claim that it's mainly the adolescents who are the leader of the language change. If this is the case, it actually gives more of a weight to look at young adults' tendency of learning if we want to understand anything about language change in addition to the language typology. However, even though that is the case, I believe that we still need to consider the child learning of a variation, child learners of the variation learning. Because as you can remember, this whole research program is to link learning, language change, and language typology. If you want to understand these by connecting these three dots together, we should really have a good understanding about the language acquisition. And without knowing how children will learn any phonological variation patterns, we cannot really completely link these three dots in a more comprehensive way. So that's more of a justification. Now let's think about whether it's feasible to replicate our study that's done with the adults to the child learners. So recall that the phonological pattern that we're adopting here is a rounding harmony. I believe that rounding harmony is a good site to look at this tendency because of the following reason. First of all, rounding harmony is the phonological cue that's available to the young children as early as infancy, and especially this has been found across the many experimental paradigms, and this is not also dependent on their experience. So whether they already have an experience of the rounding harmony in their L1 or not, that doesn't really matter because rounding harmony is very readily available cue to the little learners. Therefore, it will be a useful site for testing phonological knowledge in artificial language learning paradigm for child learners. Also, rounding harmonies, phonological domains are quite broad, so we can see the rounding harmony both within the roots and across the other boundaries, such as the morpheme boundaries and across word boundaries. So it gives us more of the freedom in designing the rounding harmony languages because typologically, this has been observed in many phonological domains. For the rounding harmony, there are three principles in terms of its typology, which basically says what is and what are the preferred pattern for the rounding harmony. So for the rounding harmony, the trigger must be non-high, the target must be high, and trigger and target must agree in their height. So these are the preferences that we can observe from the word languages where we can see the round harmony pattern is going on. And if we were to test the role of the substantive bias, we first need to check how the rounding harmony can be understood in terms of this phonetic substance. Primarily due to the perceptual reason, spreading the plus round Q is good for enhancing the perceptibility. So if this rounding harmony pattern is grounded on such phonetic substance, which then forms the substantive bias, then if the substantive bias is at work in learning the rounding harmony, we should be able to see some biased learning of the rounding harmony acquisition. In our artificial language, we have the Hong Kong Cantonese native speaker. All of them are preschoolers, and both participants and the parents' dominant language are Hong Kong Cantonese, and they all learn English in their local kindergarten as their L2. In this artificial language, they were introduced with the 6 animals whose names are in CV forms. And what children were told is that those animals are moving, and they were given 2 types of emotion verbs in CV forms. And when we consider the relation between the last CV in the animal's name and then the motion verb, we can see the rounding harmony pattern going on. For example, the name of the turtle in this artificial language is a kenu. When we say a turtle is singing, it's either kenube or kenubo. As you can see, one form has a non-harmony and another form has a harmony going on. And when this turtle is playing soccer, it could be either kenuri or kenuru. Again, one form has a non-harmony and another form has a harmony. We designed the two languages. Language A has a dominant rounding harmony. 67% of the times harmony patterns were presented, while 33% of the times what people saw were non-harmony. And then the proportion was exactly the opposite in language B. And in order to test whether the typological principles about trigger target heights are also observed in our experience, we designed in a way that the number of the high and non-high vowels, both for trigger and target, are equally balanced. During the training, child participants learned how to describe the moving animals or the animals in motion in this alien language. The alien language uses the same sounds in English, that's what they were told, but they're also told that the names are different from their English so that they can understand this as a learning of another new language. They were presented with the 6 animals in 2 motions and then is repeated 3 times, all in random orders per each participant. And they were asked to repeat after each sound file is played, and then the repetition continued until their production was correct. After the training, there were 2 phases in testing. In phase 1, what people are asked is basically the memory test. They were given the 8 pictures which are already seen during the training. So 4 out of 6 animals in the 2 motions were given. And we made sure that 2 of the animals had the same high vowels and non-high vowels that are equally presented for each participant. And he also made sure that 2 of the motions are equally presented to each of the participants. They were given 3 answer choices. The first choice was a verb with a dominant harmony or the non-harmony pattern. For example, if you're a learner of the harmony language, kenubo is a dominant pattern, while kenube also appeared, but that's a non-dominant pattern. But if you're a learner of the non-harmony language, now kenube is a dominant pattern. In the answer choice B, the opposite pattern is given. The non-dominant harmony or non-harmony pattern as the answer choice. And in C, they saw the completely wrong answer composed with the wrong consonant and then wrong vowel. After phase 1, the next phase is their generalization test, meaning they were asked to generalize the knowledge that they learned to the new items. Now they're introduced to these 4 new animals they've never seen during the training, and their task was to choose how best to describe them in the 2 motions, playing soccer and singing. And exactly the same 3 answer choices are given to the children. Before I jump into the results, here's how we read the figures in the results section. So, rounding harmony language means that the language has a dominant rounding harmony pattern. And in non-harmony language means that this is the language with a no rounding harmony was a dominant pattern. And remember, in both languages, the opposite patterns did exist, but as a minor pattern. In all of the figures, you will see these dotted lines, one in red and one in green, and dotted lines indicate the input proportions or input frequency. For example, look at the figure on the left side, which is the harmony language. In this language, the harmony patterns were seen 67% of the time. And that is indicated with the upper red line with the 67%. And here, the non-dominant minority pattern was in green, which is the non-harmony, and that's shown as a dotted green line at the bottom, okay? So Let's first look at the overall tendency we can see from the children's subsequent production of the artificial language. The one thing that we can notice obviously from these figures is that the red bars are really tall across all of the conditions, which means that overall the harmony pattern is chosen very often, which suggests a general preference of the rounding harmony over disharmony, proposing a substantively biased learning. So overall, we can see some biased learning that's going on across the two languages. Now, let's look at each of the context, both memory and generalization test. Let's first focus on the memory test and then among the scene items. Remember the scene items were the animals that are already shown during the training. If we look at the harmony language, here, as you can see from really tall red bar, people predominantly thought the harmony is the right answer, which is much higher than the proportion of the harmony that's shown in the input. If we look at the non-harmony language, here the input of the harmony was only 33%. Compared to that, as you can see, the red bar is relatively high. It's not super high, but still, compared to the input, this is high. And actually, in children's subsequent production of the artificial language, harmony is the dominant pattern, which is opposite to what input had shown to them. In the input, non-harmony was the dominant pattern. So, if we were to understand this memory test across the rounding harmony language and non-harmony language, here's the summary. The results of the memory test showed preference of harmony patterns in both languages, suggesting substantively biased learning of a rounding harmony variation. In other words, children modulated the proportion of the variance more toward the harmony patterns that can be observed both from the RH and NH languages. Now, let's look at the generalization test. Recall that the generalization tests were the parts where children are asked to generalize the rules or constraints that they learned to the new items, the 4 new animals. First, let's look at the harmony language, the purple lined one here. Compared to the considerations so far, here you will see the bars are actually really close to the dotted lines. Red bars are close to the red dotted lines, and then the green bar is close to the green dotted lines. And it turned out that there was not much of the frequency, no significant frequency between the proportions shown in input and children's output. However, if we look at the generalization test in the non-harmony language, harmony pattern here was chosen a lot. It's way higher than what input had shown. So for the input, as the bottom dotted line of the red color shows, there are only 33% of the times that people show the harmony pattern. But in the subsequent production, as you can see, harmony was really the predominant pattern in children's production. And apparently, the distribution of the input and output was very different. So for the generalization test, here is the summary. There is a quite amazing proportion match in the rounding harmony language, suggesting there is no biased learning happening in harmony language. But if we consider the non-harmony language, it is the most radical change. We can see the really radical change of the input to output because of extremely highly biased learning happening here. And children actually completely flipped the variance dominance from the non-harmony to the harmony pattern. So in our experimental design, we included the 3 typological principles as remembered. And among the 3 principles, what we're able to observe is that only principle number 2 is at work, while principle number 1 and 3, they were not really proved from our experimental result. And in fact, this is exactly the same result that we saw from the adults in our earlier studies. So with these results, I want to consider what this result means through the 5 different angles in terms of the implication of this study. First, I want to talk about the typological principle, what it says about those rounding harmony principles. Number 2, I want to talk about what this study suggests in terms of the discrepancy we can observe from syntactic and phonological variation learning. And third point to think about is the specific context from which we can observe biased variation learning in phonology. And then the fourth point is that let's compare the phonological variation learning among children and adults by comparing our old study and this study. And lastly, let's think about what this study implies to the directions of the sound change when variation is concerned. So the first point, as you can recall, out of the 3 principles of the rounding harmony regarding trigger, target, and their agreement, we can see that only 1 principle was at work, while the 2 were not really true in our experiment, both from adults and from children. And in fact, when we look at the typology, there are only 3 languages that shows the free variation of the rounding harmony, and 2 of the 3 languages actually match the principle that's going on in our experiment. So they only have the high targets without any trigger constraints or the agreements constraint that's at work in those languages. So it seems like our results, both from the adults and from children, seem to match with what's going on in typological tendency if we restrict our consideration to the languages that adopts the free variation of the rounding harmony, just like our artificial language. Now, let's consider the syntactic versus phonological variation learning. As we saw from our study, phonological variation learning is overall substantively biased toward a more natural variant, which was the rounding harmony variant. This is quite consistent with a tendency already reported from the syntactic variation learning because they found that the children actually prefer the variants that go with the typological tendency or that's more natural in terms of the syntactic naturalness when the syntactic naturalness is concerned. However, even though in both syntax and phonology, children's production reflects the typological tendency, there is quite a striking asymmetry between syntax and phonology. In our current study in phonology, we found that children modulated variance distribution. They never canceled it, but they really just modulated some proportions of the variance. But in syntax, as you can recall, we saw that children completely regularized the languages. Even though they were trained on non-harmonic word order, for instance, they still thought the typologically best supported harmonic word order should be the answer, and they regularize it completely. I think we're still too early to really make any big story out of it because, especially in phonology, I think we don't have enough evidence to really believe whether our result is solid or not. So first, we should check is maybe with the other phonological patterns and from the other populations, we should first know whether the current results are reliable. If we find that this is the valid result, then the following question is, where does this discrepancy between the phonology and syntax coming from? I don't have any specific idea about it, but the rough speculation about this discrepancy is as follows. For the syntactic learning, the core task of the learning is figuring out the structure relation among the components, such as in relation to the noun, where should we put the adjective? In relation to the noun, where should I put the numeric modifiers? In phonological learning, learners should figure out such structure relationship, especially the morphology is concerned, but phonological patterns are, most of the phonological patterns are grounded on articulatory, acoustic, and perceptual cues. And I believe such cues are more immediately available to the listeners. Therefore, during this short exposure in artificial language, maybe such cues are facilitating learning so that learners are in a better position to track the proportion of a variance. We, as I said, don't really have any story about it, but currently my lab at HKU is working on the comparison of the syntactic and phonological variation learning. The third point I want to think about with the current result is the specific context from which we were able to observe biased variation learning. So overall, the learning was biased, but as we saw, such a biased learning was not observed from the unseen items in the rounding harmony language. So remember that in the purple case, there is almost perfect match between input and output, which suggests that when you're generalizing your knowledge to the new items in a natural language, which is a rounding harmony language, children generalize the distribution without really imposing a substantive bias. But in a non-natural language, non-harmonic language for our case, the generalization was really in a highly biased way, suggesting that the substantive bias guiding our phonological variation learning more radically when the patterns itself or languages themselves are more unnatural. And the next point I want to talk about is the phonological learning, the comparison of the children and adults in phonological learning. So there is a parallel between children and adults. Both of them showed a substantively biased learning, and there is a significance of the only target height when we consider the principles. A major difference is that adults didn't really depart a lot from the input. They matched the proportions pretty successfully, but for children, they completely reversed the non-harmony distribution, both for the seen and unseen items. And this is actually quite similar to the patterns that's observed in the syntactic variation learning, that children are more biased in learning these variation distributions. They didn't really entirely regularize the language as we observe from syntax, but this has quite a similarity if we compare the syntactic variation learning with the phonological learning. So we interpret this as the children ready and able to rearrange pluralistic constraints from what they see from the input. The last point I want to talk about is the prediction toward a sound change. So let's go back to the link between learning and typology, which is the whole starting point of this talk. If the variation learning is biased, as we observe from this study, as the time goes by, learners will reshape our language in a way that is more skewed toward the natural variant. But as we know, not all of the variability will die out. Some of the phonological variability will remain, such as an English ing and in. And why is that a case? If our prediction about the sound change is correct, maybe in a very radical situation, we would have predicted that only natural variable will survive, but that's not the case in natural language phonology. And I think our study results actually have a good idea for that. It's only from our non-harmony language that is greatly restructured by our learners. It's not from the harmony language, but really from the non-harmony language where the generalization is really biased. This suggests that there must be some kind of what we call a tipping point, so that the learners may decide that they need to change the distribution of the pluralistic patterns. A pattern or the variance must be unnatural enough so that any kind of changes can happen. If the two of the variants, such as the ing and in, are natural enough and they are acceptable, presumably, even though some changes might happen, but still such variabilities might remain. Okay, so thank you for listening, and I guess we will move on to the Q&A session.
Thank you, Youngah. This was really interesting, actually. And yeah, we learned a lot about harmony, and I also noticed that our both talks today are about harmony systems, actually. So it's really great. If you have any questions, please send me your name and affiliation throughout the chat message. You can directly send it to me. So While we are waiting for some other people to gather their thoughts, I think Shigeto can ask a short question first, like just to begin the session. Yeah.
Okay. Well, thanks, Yona. That was great. I always learn a lot from your talks.
Thank you.
The one thing I've been doing during lockdown is to reteach myself Bayesian thinking, Bayesian learning. And I was wondering if you could capture the difference between children and adults as different as prior expectations about how phonological patterns should be. So it looks like kids seem to have stronger priors. They want to move toward phonetically natural patterns, whereas adults, they don't have any high expectations about any pattern. So they just go with any kind of the data that they're given. So would you be interested in, like, you know, modeling this difference in terms of Bayesian reference?
Yes, that's actually a very good direction to go. For our adults data, actually, we model the experimental data in a Maxent grammar before, and it turned out the tendency that adults were doing were also predicted well, but that's not so interesting. As you said, for the adults, they did what they're asked to do. So for the comparison between adults and children, as you point out exactly, I think the core point should be the different ways of the priors. But at this stage, we don't actually know like how strong of the prior should be assumed for the child learner relative to the adults, especially due to the insufficient results from the experimental side. So if we have a more sufficient evidence to believe that children are way more strongly biased and yes, more strong prior to start with, that might help for modeling this data for the Bayesian modeling, I guess. Yeah,
that'd be interesting. Like, you know, Colin Wilson has already done this when he, you know, modeled the phonetic substance by max and prior. So yeah, something interesting to think about.
Thank you.
Thanks.
Next is Andrew Lamont from UMass Amherst. Yeah, please go ahead.
Hi, Youngah. This is a really interesting talk, and I was just curious if you've considered whether, in addition to the substance bias, there might just be a general rule application bias. So this is something that in his work on opacity, Kaparsky talks about as preferring, say, counterbleeding opacity over counterfeeding, just a general preference to apply rules. So I was wondering whether, or asking whether you've thought of or have looked into, say, doing something similar, but where the minority rule that's being applied isn't enhancing any phonological feature. It's just, say, some arbitrary, say, vocalic rewriting, and just to rule out something like an application bias.
That's a very good suggestion, and especially for the syntactic learning side. When I read those papers, well, they interpreted this result as an extremely strong bias among child learners to go with the typological tendency. But another way to think about it is exactly as you point out, maybe children may resist applying rules, like overall, or in a more radical case, they may not learn anything. They just have a certain preference, and whether they were trained on an artificial language or not, that doesn't matter, and they just choose whatever they prefer. So yes, in order to really understand how much of the learning based on the substance is going on, exactly, we should really see whether this can be really interpreted as the learning result, and as you point out, some kind of a crazy rules or a minority rules not really grounded on any substances should be tested. Definitely, that's a very good suggestion. Thank you.
Cool. Thanks.
Thank you. The last question comes from Seunghun Kim. You will have more questions. Somebody who wanted to have questions will have more time in the breakout rooms, but the last question for this main session will be by Seunghun Kim from UMass Amherst.
Hello. We never met, but 안녕하세요. I was just wondering about the result. So I've noticed that for unseen items specifically, the proportion of choosing harmony forms was actually way higher for non-harmonic language learners. And then I was wondering if it means anything. And then actually, like toward the end of the presentation, when you mentioned this tipping point, I was wondering if it could be interpreted as some kind of urge for the tipping point. So yeah, I was just curious.
Yeah, exactly. So compared to the harmony language, as we can see from this slide, both from the seen and unseen items, the variant dominance has been flipped, right? So they were trained on a language with the dominant non-harmony pattern, but the subsequent production was the opposite. The way that I interpret it, as you just point out, is that maybe the learners interpreted this as that this is really the unnatural setting, therefore something must be done. And that's what we interpreted as a tipping point where the sound changes might be initiated. While in natural language, where the variation distribution is more natural, and even though the two variants are going on, their proportions can still remain through the processes of the sound change. Yes, so the dominance has been apparently flipped in this side. Yeah. Does it answer your question?
Yeah, thank you.
Okay.
Yeah, thank you. Thank you. Let's thank Youngah one more time with applause reaction. So thank you very much. And this was, let's stop the recording at this point.